Two new Tesla products are now on the horizon, and they're the kind that make you sit up and pay attention. For years, the idea of a Tesla flying car felt like a distant rumor or a concept reserved for science fiction. But now Elon Musk has gone on record. It's unveiling a groundbreaking project that doesn't just extend Tesla's current lineup, pushes into a completely new dimension. This isn't just about making another electric vehicle. It's about introducing something so different, so radical, that it could spark a transportation revolution as early as next year. The big news? The Tesla flying car isn't a distant dream. It's reportedly already in prototype production at Giga Texas. The fact that Musk is managing to juggle this alongside all his other projects is astounding. Beneath the surface, Tesla is quietly developing driverless robotaxis to take over city streets. And above our heads, there's now the very real possibility that we'll see Tesla's first flying cars lifting off in 2026, while it's expected that the vehicle will still require a special pilot's license due to safety regulations. The most jaw-dropping detail might be the price. Leaks suggest it could cost just under $10,000, making it one of the most affordable personal air vehicles ever proposed. If these reports are accurate, the Tesla flying car may actually be easier to produce than most would expect. Musk has hinted that many of the required components already exist within Tesla's production ecosystem, and the Giga Texas facility is set up to adapt to new product lines without starting from zero. That kind of infrastructure flexibility is one of Tesla's biggest cost-saving advantages, allowing them to build innovative products without massive new investments in tooling or facilities. But why take on a project this ambitious? For Musk, the answer is rooted in one of the world's most pressing 21st century challenges: traffic congestion. Imagine bypassing hours of gridlock by simply taking to the air. The idea isn't just about speed, it's about extending range, cutting travel costs, and freeing people from the limitations of traditional roads. For many, it's a thrilling prospect, a vehicle that can operate as both a car and an aircraft, revolutionizing how we think about mobility. Still, excitement isn't the only reaction. There are significant safety concerns to consider. Flying demands far greater precision and skill than driving. A small technical failure or human error in the air can have far more severe consequences than a mishap on the road. Statistically, survival rates in serious aviation accidents are much lower than in automotive crashes. This means Tesla will need to design its flying car with absolute safety in mind. From its aerodynamic profile to its flight control systems and automated emergency prevention mechanisms, there's also a strategic angle. While Chinese automakers have quickly learned to replicate Tesla's EVs, sometimes within a matter of months, developing a flying car is a much taller order. Analysts suggest it could take China years to catch up if Tesla successfully commercializes the technology. Insiders claim the Tesla flying car will borrow heavily from Tesla's highest performance models, like the Model S and the Roadster. These platforms already have proven powertrains, battery packs, and chassis designs, which will help reduce R&D costs while ensuring high performance and reliability. But performance alone isn't the priority. Safety remains the top concern. To achieve near-zero risk, the flying car will need to meet stringent aerospace-level standards. Leaks suggest Tesla is already incorporating many of its current EV components into the design, such as high-capacity battery systems, advanced electric motors, and next-generation autonomous driving systems. Using existing parts not only cuts costs dramatically, but also allows the company to hit that sub-$10,000 price target for a personal flying machine, a number that would have been unthinkable just a few years ago. Interestingly, this isn't a purely solo effort. Musk is reportedly collaborating with Klein Vision, a Slovakian company best known for creating the aircar. It's the first two-seat flying car to earn an official airworthiness certificate from the European Union Aviation Safety Agency in January 2022. This partnership isn't about copying Klein Vision's vehicle outright, but about learning the engineering principles and design approaches needed to bring a flying car into mass production. Klein Vision's aircar is a remarkable achievement in itself, with over 170 hours of successful flight tests and more than 500 flawless takeoffs and landings as of 2025. It's proved that transitioning between driving and flying can be a safe and reliable process. The aircar comes in 3 engine configurations: 280 horsepower, 320 horsepower, and 340 horsepower, all V6 South, comparable in performance to luxury sports cars like the Porsche 911 or Lamborghini Urus. The 280 horsepower model is the one targeted for wider production, balancing speed, efficiency, and lower operating costs. While it's an aircraft at heart, the aircar retains familiar car controls, a steering wheel, accelerator, and brake pedals, so drivers don't have to completely relearn their instincts. Its wings fold neatly into the body, and the tail retracts automatically, giving it the sleek profile of a high-end coupe when in road mode. The design is deeply aerodynamic, reducing air resistance by 40% during flight and generating natural lift for better efficiency. Large panoramic windows give a clear 360-degree view, critical for navigating urban environments from the air. In terms of performance, the aircar can reach 124 miles per hour on the ground and up to 155 miles per hour in the air. With a range of around 497 miles on land and 621 miles in the sky, its 3 fuel tanks can hold a combined 42 gallons, and it can refuel at any regular gas station. Physically, it's about 19 feet long, 6.5 feet wide, and 6 feet tall, close in footprint to a Rolls-Royce Phantom, though lighter and with different proportions to store the flight hardware. Despite its size, it weighs just 1,764 pounds. Thanks to carbon fiber and Kevlar composites that make it extremely strong, yet lightweight. One of the aircar's engineering standouts is its use of aerospace-grade honeycomb composites materials, also found in fighter jets for wings and tail sections. This keeps them light, but exceptionally durable. The transformation from car to plane takes under 80 seconds. The driver shuts off the car engine, presses a button on a touchscreen, and the wings and tail deploy automatically. The V6 starts. The vehicle accelerates down a short runway, and at around 75 miles per hour, it's airborne. The whole process reverses in less than 2 minutes for landing. Making it practical for real-world use, ClineVision plans to begin customer deliveries. In early 2026, an operating one will require both a driver's and a pilot's license, along with 2 or 3 months of training. This sets the baseline for what Tesla will have to consider. Though Tesla's version is expected to diverge in a key way, it will be fully electric. Switching to an electric propulsion system fundamentally changes the equation. No combustion engine means zero direct emissions, less noise, and potentially lower running costs. It's a move that aligns perfectly with Tesla's sustainability goals. However, the challenge of electric flight lies in balancing battery weight and capacity. Too large a battery adds weight and reduces range. Too small, and it won't supply enough energy for sustained flight. Tesla's ace in the hole is its battery technologies, specifically the 4680 cell. These cells have an energy density of around 300 watt-hours per kilogram, allowing a large amount of power storage without excessive mass. By leveraging these cells, Tesla can design a battery pack that gives the flying car sufficient flight range without compromising its weight balance. That balance is crucial for both performance and safety. An electric flying car from Tesla would offer multiple advantages over combustion engine equivalents. Not only would it be quieter and more eco-friendly, but it could also integrate seamlessly. With Tesla's existing charging infrastructure, imagine landing your flying car at a vertiport, plugging it into a supercharger, and being ready for your next journey in minutes. The company could also draw from its full self-driving software to enhance flight control systems, adding layers of automation to assist pilots and prevent accidents. Still, achieving this will require breakthroughs in both aerodynamics and battery efficiency. Even with 4,680 cells, optimizing every aspect of the vehicle's weight, structure, and power usage will be vital. But if there's any company positioned to do it, it's Tesla. Their vertical integration, control over battery production, and experience with high-performance electric drivetrains give them a head start no newcomer could easily match. All signs point to early 2026 for the debut of Tesla's first flying car. They can hit the rumored sub-$10,000 price, would radically lower the barrier to owning a personal aircraft, something historically reserved for the wealthy or professional pilots. Combined with the possibility of widespread autonomous flight assistance, this could open the skies to ordinary commuters in a way we've never seen before. The implications go beyond convenience. A mass-market electric flying car could disrupt urban planning, reduce the need for traditional highways, and even change where people choose to live and work. It could also create a new technological arms race, the competitors, especially in China, scrambling to match Tesla's progress.